This is the group that's working on what we refer to typically as the WOZ project or HPU minds. And as we discussed last time, they're working on using a brain-computer interface to try and control a device of some description. So I'm going to turn it over to Joe Davidson, sorry, who is the, I guess, lead, if you will, for the project right now. And he's going to quickly bring us up to speed and start harassing you with some questions. And I'm going to quietly stand on it.
Should I stand up or?
You can do whatever you like.
Okay.
He probably wants to know who you are, so waving at him.
I'm Joe Davidson, lead of HPU Minds. I'm a senior here at High Point University. Thank you so much for coming out here again. It's wonderful to see your face again. We have two Ultra Cortex Mark IV headsets that we've been using to get brainwave data. And what our goal is now to get a light switch turned on and off using our brains. And then going from there, starting off with the vehicle with the chassis, controlling four wheels, directioning, and then hopefully if we can do that, adding a robotic arm and kind of extending on to that.
Excellent to get experience with one small part of the project. Yes, good to start that way.
So we've definitely
I meant to wear my helmet all wired up, and I had to rush out today and forgot it.
We forgot to bring ours too. Good idea. So I guess my first question to you is, what's a method you would recommend with overcoming general difficulties or obstacles during a big project? I know they come up all of the time.
Mm-hmm. Well, the big one is always overcoming your own phobias and to have your own self-confidence and not to be unsure of yourself, to say, I have certain techniques, some training I have from the past, and this is the step I'm going to apply it in to get to the end solution. And knowing that you've gotten to small solutions in development before is a big help in that regard. The first thing is to think about the problem in your head mentally. You know, you can make notes on paper, but try to get it to where sometimes you're going to sleep with nothing else to do. You're not wasting time or anything, and just try to think out the solutions and the steps you're going to do in order, because I'm a big logical guy. Arrange things. Have an organization in your head as to what steps you're going to take. Obviously, when you're working on problems, any pieces, it could be hardware, software, it could be architecture, but bugs come about. And, you know, bugs that you can't really create are so elusive. Oh, how do I get from here to there? And really, it takes an awful huge amount of dedication, sometimes oddball hours to get those things done. Also, it's good to look at something you're doing and maybe print out any intermediate states of the situation that you can, whether it's certain software states or result states, and try to analyze them, look at it and see exactly where the ones and zeros are going, and microanalyze it, you know, right down to the little level of, you know, is every step, say, in my software working and doing what it should? Obviously, think out of the box. Can I do something to improve it? Also, what you suggested is a good one. Take a little subset to start with, a subset of the solution, and get that working first. Always work on small pieces. One of the things, whenever you get to big data and how do I organize it and make sense of it, and then, of course, you learn this in CS classes. If you can break a problem down into several small spots, solve the small ones individually, that's sometimes a way you can solve a problem that's otherwise very difficult. Obviously be patient and be careful with what you do. The patient person will get to the point that you can get repeatability. And you should probably sometimes have some projects that one person takes a certain subset and takes responsibility for it and really gets to work on it very independently. Because sometimes it takes one mind knowing that they are in charge of this partial solution, this subset of the whole program, to actually make it there. And it's harder to do sometimes when I think, oh, I've got to count on the group and I can't leave the group behind and I've got to slow down, because you really do want to get, you know, to complete solutions. and also consider alternative architectures. You know, you put into a solution, right now it's mind controlling a robot, sphere or whatever. And, you know, but consider, oh my gosh, there might be a whole different approach to putting this thing together. It might even involve other pieces, different makers of brain muscle sensors and all that. It might sometimes be, once you've got it in your head, here's how we're solving it. And if it's not very reliable, could we go back and improve it, write the software a second time, a whole different angle we might come in. That's where a different architectural approach will solve different problems first to put the total together. Sometimes that's a solution to these sort of problems, and you basically can redo it from the start in a short amount of time. It might have taken you months to get through it, and something's holding it up. You could redo the software. Say, I want to make it clean. It's full of all this stuff we added on, and sometimes they conflict and they're buggy. What if we redid it from the start, and then you can go back? Something that took months, you can redo, usually, you know, in 2 days to a week, because all the parts that you've gone through so far are in your head.
Interesting. Thank you. So my name is Cam Bortle, and I'm a junior here at HPU. It's very nice to be talking to you. So I guess I just want to let you know on some like the progress that we've gotten done so far with this project. So right now we're kind of stuck at this one point where we have the data. We can read it in, and we've written it to a text file. And right now the data is basically, it just looks like a bunch of numbers that we really don't know what they mean, and we don't know how to use them. And I guess like my question of that is like, how would you go about when you have like a big, like it's a lot of data that we're getting, like how would you go about like sorting that and trying to figure out what it means?
Okay, I had a bunch of like family emergencies for quite a few months, so I didn't get to actually getting into solving the project myself as I had intended. But I presume that you're getting several tracks of ones and zeros that are coming out of different brain sensors, and you're trying to make sense of them. Am I correct about that? You're not sure how to minimize the data and make better, higher level sense of it?
It's not so much ones and zeros, like it's just like a bunch of like numbers that it can be really any number really, but we just don't know what they mean quite yet, because I'm not really sure if any of us know how to read like from the GUI from the brain scanner. Like we don't know like what any of those graphs are like really saying. So we don't know like the numbers that we're getting from those, like, yeah, we don't know what.
Then that's your big subset job for now. You must have researched it though, because other people have done this and tried it, these very similar things, and have answers online. Lucky we have the internet these days. The best of all, of course, you get a much better understanding if you look at the numbers and try to say, is there some way that I can put these numbers through some mathematical process? We speak of neural networks. That's the job of neural networks, but we spoke in engineering terms of Fourier analysis, fast Fourier transforms, where we can take like all the data of a sound on a wire, all the voltage points, and then bring it down, and fast Fourier transform gives you which frequencies are being there. And that's what makes more sense, is when you can reduce the amount of data just the same as the brain cortex does. But if you find your own way, if you work on it, that takes motivation, and it takes a lot of hard work and a lot of time. You know, and if you're not motivated enough to put the time in, if you don't think it's that special in your life, well, figure out what is special in your life and at least work on that or go in that direction.
All right. So some other progress that we made is with this brain scanner, we noticed that every single, like Landon right here is usually our guy who's wearing the helmet, right? So we noticed that if Landon's wearing the helmet, every single movement he does, when we look at like the plot chart of it, where we have like every single node of the helmet, with every movement you can see like the activity coming from every node. And we also notice every single time like you move your head, you get like a big spike in all those nodes. So I guess it's like another thing is we don't exactly know.
You're trying to do some sort of data analysis to make those numbers usable, or what they mean, or are they reliable?
I guess we don't know that yet.
And repeatable, that means, are they repeatable? You kind of get the same sort of numbers for the same body actions or whatever. Now, right now, you're taking the sensors on your head, right?
Yeah.
because you had an option to put sensors on, you know, muscle triggers in your arms. So if you raise an arm, what is your head doing and what does it mean? I guess you want to get to the point that you can kind of steer the robot. I mean, that would be just so impressive. How to figure out what the numbers mean. I just stare at it and analyze it. Now, it might be you want a mathematician or, you know, especially an engineering student who's into mathematics as well, to try to come up with some correlation, because sometimes you have to sample, and take kind of like average things out. Try to figure out what is you know, the number that's really there, but don't judge spikes. Don't judge spikes. I always say we call it dampening in electrical engineering. Dampen the results in your head. Don't jump quickly to any conclusion, and sort of just wait it out and go peacefully. You might also be thinking of, oh, I want to see instant results. Just hold a hand there and see if something settles down. Maybe it gives you some clues. These are just my own ideas, though. I mean, you can come up with just as good ideas, I hope. I'm not there, and I wish I were, because I'd love to sit down and look at the numbers. Put them in a spreadsheet and then use some of the formulas that find curves, like least squares fit, or, you know, others.
Okay, so you're saying we're better
Lagrange
off.
equations. Yeah.
Sorry. So you're saying that we're trying to get a bigger picture of all the data rather than just judging by like an instant happening.
Well, you're probably looking at maybe some instant. Yeah. Oh, yeah. If you look at a very instant thing, let it average out over time. And also, you may be looking at one number and not see that there's slight variations in the others. And it's the whole total maybe adds up to some, the correlation of it maybe adds up to something that has meaning as to what you're doing, I guess, with your body in this case. But I presume that from the helmet, you're recording, you know, a lot of numbers simultaneously. And now you got big data, and big data analysis is really mathematical. I don't know if you've got mathematicians on your team, but it's out of the sight of just, writing programs, you know, that operate and do what you want to do. It's this deep level of programming.
Okay.
Hello, I'm Landon Hardister. As he mentioned, I'm a freshman computer science major at High Point. And so I know you mentioned that you had some medical emergencies in your family, and I'm sorry to hear about that. But what have you gotten accomplished with the headset, and like, what are some things you could share if you played around with it?
Our family medical emergencies were very deep. One even resulted in a death, and we had to spend so much time kind of watching someone in the family with cancer that I pretty much dropped the ball on this and didn't take the helmet further into. I was going to get my own numbers out. And last time we spoke, and the helmet's sitting right in front of me in my office where I work, but I'm just getting back to life right now. Busy month. So expect more maybe end of December.
All right. Thank you so much.
Thank you.
Okay, any more?
Yes. So when we hear about people talking about production, production and efficiency, we hear about, let's say, taking a break every 15 minutes out of the hour. What do you find, like, which techniques do you find best that help you maximize
productivity. The best I found for productivity was no rules. Don't follow any rules. Don't make up rules for yourself. Just how you feel. When you feel like, my gosh, I want to work on this. I want to solve this bit of it now. I want to study it and try to come to some understanding of it. Or it's not working yet. I've got to get it working. Your own drive, your own emotions should guide you. It's kind of like, when should you sleep? When you're tired. I'm sort of one of those, and so let your body have some say in your activities. Obviously, you should allow if you're working on a session, let's say you get together and meet briefly, maybe an hour, maybe 2 hours. Oh no, allow it to be extended. You know, go home, keep thinking about the problem, keep working on it on your own time. I found that all the things that got me to where I got in life, the best ones didn't come from studious academic schedules. They came from when I did things on my own and thought them out because I wanted to, not for businesses, not for grades, not for any real results, but I really wanted to get to do it because I was pretty sure I would get to a solution. Every once in a while, you take on something like that that's risky and it does wind up being impossible in the end. You should always have virtual follow-ups with your other teammates that are working on similar things. You know, maybe schedule them. But one thing I do not like about meetings in a company or even here is go in and, in a half-hour meeting, a 1 hour meeting, somebody will make some proposals and we'll have to decide yes or no or what to do. Wait a minute, not everybody's brain works that quickly. I always like to go home and take a couple of nights sleep on it and then come up with better ideas and meet again. So always be willing to revisit your, your sessions and do a lot of thinking outside of the session. You know, what things might have been talked among you. Here's what we might do next. Well, don't be afraid to think here's something very different that we might even attack. Even we might even change what the end project is actually. Have individual goals and know what, the individuals having goals is the most important thing to getting completed. And you don't want to just speak about ideas. In the end, you've got to be motivated we want to get results. We actually want to show something. If you don't feel it strongly inside of you, get it in there. What's in your heart is where you'll do best and where you'll go. And members should pretty much sign on to, maybe different parts of maybe sub-projects but show the work. Don't just do it, but be able to show it. Obviously, seeing numbers is part of the showing. So that's good to know about. But be strict. Be strict. Just like academics, you got to sometimes, pay attention and put, it's worth an awful lot to put into it. But in a project like this, be strict that you're really working on it and not just, I'll just put it off till it passes by or something like that. If you're feeling that in yourself, please notify your project leaders and all, because I don't know, every technical project I've been on was a lot of hard thinking, a lot of hard brain work, and then getting through to solutions. Sometimes in advance you will get to the solution. In this case, it's hard to tell, very hard to tell, because you're like me, never used these brain scanners before, and try to apply them to spheros. The best you can do is go online and try to find people who've done it or done very similar things and read about everything they have to say. That's how I do my research on projects these days.
Okay, thank you. Is there anything in particular you would like to see come out of this project?
The main thing for every project, even that I engage in myself, is your own learning. How to apply some bits of what I call atomic technology. That's the little basic technologies, like the brain scanner itself, and how it can be applied. And the fact that you've had experience with it means you'll be able to do it effectively further in your own life, even if this project doesn't come through as complete as you can think of. Now, the nicest thing in the world would be to actually be able to sit down and control with your thinking, your arm movements, control a robot, make it move. It doesn't have to be perfect either. That's because it's very unusual. I wouldn't expect that, oh my gosh, I can just think and steer a Ferrari in a race. I'm just going to race it around. It'll probably be more like a camel when you're done. But no, that'd be really good. I would love to see that from your own learning on this project, that you influence other students around to say, oh my gosh, these guys went in there and tackled this project and look what they did. Something I wouldn't even have a clue to know what to do. You might inspire other ones to even, want to head in the engineering direction or something. These are kind of neat things in life. Your team certainly should get that kind of recognition, but I hope you get into further such projects. Finish one and say, here's something else we could do that's even more, because, especially if you complete one to some extent and have something working, it's nice to find the support of the university. It translates to money in the end. And I hope some of you actually engage in startups in the future. I hope you have kind of a neat experience. This is what it's like to create something new that didn't exist. It's hard, and it doesn't come about easily and trivially. And by sticking with it and having what the common word these days they like to use everywhere is called resilience, but not giving up and keeping at it, is so important. And you're going to go ahead with greater minds. And you're going to be able to reach greater goals in your life. A one shot like this doesn't have to be something that's in my life. I had tons of these little projects for fun, and none of them had to be like worth a company or something like that, or worth much money, but still things that I could show off to my friends and smile, made me feel better about, myself and what I was doing, that engineering was valuable to me.
Thank you.
The question we have is, so you mentioned about singling out specific data in order to try to condense all the data that we're bringing in through the headset itself. Do you have any ideas about how you would single out that data, and an example to be able to turn on and off an LED at first to work on a small subset of the project?
I've been around people who did solve those sort of problems, but I was not one of them. And I think there's just got mathematical formulas that, try to make understanding of what seems like random data at first. Is there anything understandable in there or not? And I can't give you real strict advice on that. That's more, do the research. I would go online and try to find people who have made sense of the brainwaves. Look for the specific scanner even. And I mean, the internet is almost unlimited with solutions these days. In the old days, you had almost no choice. You kind of had a book, a manual, and that's about it, and a couple of comments and statements on it. No, but nowadays, finding somebody who's actually done it, that's young like yourself, in the university, or in a high school even, and they love to write about their experiences, or better yet, don't be afraid to communicate. Don't be shy like I was. Don't just say, oh my gosh, we have to do everything ourselves. No, make email contact with others who have been doing this kind of stuff and made it work, and compare your stories to theirs. I mean, and take notes and share it with your group.
Thank you so much.
So another question that I had was, again, the end goal of this project is to say something like a remote control car that has an arm on it, so it can pick things up and things of that nature. So from a hardware point of view, how are you taking something that's code and actually implementing it into this machine to make it do something?
Well, first of all, you've got to analyze the code and say, what is the intent of the user? And you may have certain gestures that bring about certain brain waves. You may nod your head. You may twist your eyes a certain way. You may just think really hard a certain way. And once you can put the data, those numbers, into a meaning, well, the meaning shouldn't be that hard as to create the program. I mean, spheros have APIs, and here's how I can send it a set of signals. Then again, this is another one of those cases. Find somebody who's controlled spheros, even with equipment, not from your brain, and how do they write the program to take high-level concepts such as, move forward, or turn right, or lift your arm, or, look at their programs and their examples. Examples are the best things you'll have in the world for what is possible. Once you know it's possible, then it's up to you to use your own brains and get there.
Thank you.
My name is Rafiq, and I'm from Togo, West Africa. I have a question. Taking into consideration the access of internet in developing countries, how will someone go about building a startup in technology? Let's say, for example, in cybersecurity, for example.
Okay, you're back a ways, and the audio here was very unclear, kind of coming in and out. We don't have the best audio bandwidth to begin with for everyone, so I missed that one.
Yeah, right.
Yeah.
Oh, okay. I say my name is Rafik and I'm from Togo, West Africa.
Yes.
I have a question about building a startup or a company in technology. Taking into consideration the limit of access to internet, how would someone go about building a startup in technology in developing countries?
Building a what in technology? Oh, a
A
startup.
startup.
Oh my gosh. Startups, the most important thing in the world to me. Um, the startup experience is one like what you're going through. Very hard, uncertain at times. Almost always the startups are that way. And how are we going to get past it? Sometimes you need just somebody who's got experience or skill in a certain area. But the startup is also from the hard work. If you work that hard, a lot more hours than you think you have to on something. If you complete it, it's the greatest happiness ever. Look what we're doing. Most startups are so busy from day one. It's like, we've got to get things done very soon. We're working on the next step. Everybody's in line. You don't have full time to work on it like a real startup. When it comes to a startup, there are different approaches. The ones that are most common for young people like yourself is starts with a technical thinker, with an engineer who knows how to build something. And maybe some friends say, oh, we could actually start a company based on that. So that's engineering driven. Business schools teach you the opposite, that you learn business practices and marketing and analyze what the world could build, and you write a business plan. Here's what we would like to do. And once you get it done, you get funded. You go out and seek money. And if you get enough money to start a company, then you say, oh, we'll go find the engineers to do it. I do not believe in that at all. I think engineers should be involved right from the very start in any startup. The most important key elements for a startup, I speak about this very frequently from what I saw at Apple. Why was Apple successful? And maybe some others weren't. And it turns out that we had really good business professionalism, like an adult in the house. Very good marketing from that adult, and eventually Steve Jobs was such a good learner. He was business and marketing. He wanted to succeed, and we had great engineering from myself. Engineering, marketing, business. Be prepared. They could be in one person. They could be in two people. They could be in three people, but make sure you have strong elements of both of those. Don't say, I'm just going to go out and build something I can think of that might make the world a little better. You've got to be out for excellence, to be like the best in the world. We're going to hire the most excellent people or work on them. We're going to work harder than anyone else, and we're going to get further along and do more than all the other people in the world that have the same thought. In my travels, I will find in many parts of the world the same thinking about what a next great product should be. And, even before social web, people were talking social web all over the world, but very few of them actually went and took the steps, put it into practice, made it something real, realized it. So that's the purpose of a startup, is you're making something for real. Secondly, be aware that even though you're making something good that has value, you may not attract many people to it. They might say, well, the alternatives are good and there's competition and I'd rather do this with my time. And when you find that, in any startup, you better be ready to turn in whatever direction has people that want what you have. You got to understand that. It's called marketing. And if the market turns out to be different than what you started out to make, go in the new direction. It might turn out that you're making something to control personal robots, personal assistants in the home. You could then wind up saying, well, we have some technology that kind of works, and we can make some robots that have a good application in business or in training or in factories. And, you can always go in a different direction because you get the knowledge, and that lets you make those choices. If you ever have a startup, this is to the gentleman from Toto, I guess. If you ever have a startup, be flexible. Be flexible. Whatever your ideas are, whatever you're creating, be ready to move and change direction. Find here's a better way we can do it. Always listen to that. Be objective and don't have this not invented here. If you come up with an idea, don't say my idea is what we have to do. If you hear some other little things that could make it better, be willing to go in those directions. Don't say it all has to be your own, because excellence is what sells in the end. You have a product that's more excellent than the others. Apple could tell you a bit about that.
Thank you very much.
Yeah, I just want to add another question. This is getting back on track of the scanner itself. So a thought that I was having is, so for someone who speaks, would the scanner need like a different like criteria for someone who speaks, for people who speak different languages? Because if the goal of this project is to think, if you think for this like RC car, you think go left, is that, and you know, in English you say go left, but in another language like German, you would say something else, you know, whatever that means in German. Like, are those like inherently the same thing, or is there something that you would need to do to like overcome that language barrier that's coming from like your thoughts?
I was a psychology major in college for my final year, and I never came across anything that acted like the brain must operate differently. But do we know how the brain really acts? Do we know anything about how the brain is wired? I'm going to tell you the truth. No. Do we know that your memories are in the brain? No, we don't. We just assume they're in the brain because the brain processes memories very, very well. The brain is kind of doing the mathematical analysis. Two different cultures, what they think about it, you know? I mean, I don't know. How would you express it? Um, Left, yeah. What if you're saying left in a certain language, but it's words that are kind of like right in another? Would that trigger different? This is a better question than I thought it was. I thought that just where you're thinking is what you're measuring with this scanner. But since we don't know how the brain works, we don't know that. Maybe somebody's done some research and gotten some data that sort of says, yeah, they do have to do it very differently in a, like maybe an Asian culture where they don't have letter words, Roman languages, or maybe in a culture where the writing, like, you know, Arabic and Hebrew goes from right to left and words change. Maybe a little different, but I don't think that's important to address at first, because all that would be is taking those numbers that are coming out of this machine and writing a different algorithm for what a certain set of numbers means. It might be just a different set. So yeah, you might have to apply it to different cultures. That also implies, though, young people may not think the same as college age kids, who might not think the same as you know, older adults like myself. Huh, huh. Now there's a project. If you could find answers on that, that's true research.
Thank you.
That'd be worth a lot to the world. Maybe not. I don't know. Maybe research people don't pay money for that, but it's very intriguing. The anthropological approach.
Put you back on the list, Joe.
Yeah.
Go for it.
Okay, so another question that we had was, how do big advancements in technology such as the iPhone or other types of software that have come out along the years, how do they come to be, and how do they kind of become predominant?
Well, you know what? The things that you know, you can create a great project with the greatest engineering skills and scientific skills, and maybe it doesn't reach as many people. Maybe a lesser product reaches people, and they always say in business it's marketing. I'm not a businessman for that reason. I'm an engineer. I believe in, you know, what something can do is what its value should be. But you know, how we can manipulate it. We can make a deal with a friend over in this company and you know, turn these things into real big things. If we're already a big company, we can often, it's antitrust. It's pure and out antitrust. But we say, we have a big market buying one product. We'll just add some other kind of, like a little app to it, a certain app to it, and kind of sort of lead them, almost force them. It's the push approach. We'll push them into this new thing we have, and we got this huge numbers of people now being pushed into this new thing. I prefer the pull approach, you know, and Apple does both. Apple doesn't really do so much. The pull approach is you make something so good that people are just attracted to it and have to have it. Very difficult to say. You look at the little technologies that are coming out of physics and chemistry, you know, I'd apply to new batteries, for example. But you look at all those little developments, and it's a long, long way from the science of a new development. Maybe it's putting a new little type of atom into some chips and it makes them go faster. but it's a long way from developing that basis underneath, testing it out for a long time, proving how it works, optimizing it, getting it right. And then eventually, you know, it works into products and makes them so good that they become very big and successful. A lot of the ideas, but look at some of the most successful ones in our lifetime. Apple, all the big computer companies said personal computers were not going to happen. Google was just a couple of kids out of college. Facebook, you know, oh, we're going to get friends together, but then it gets, how do we make money? You know, but it was just young people willing to take a new approach because they're not stuck in the old ways. But once a new technology comes about, you know, chips are faster. Oh, we can put it in our computer and we can make the screen have better resolution. Instead of looking like cartoons, it'll look a little bit like real people, you know, and taking those steps. So eventually, when you have those small technologies, a new building piece, a new type of lumber, that's how you build the bigger projects. And my approach is look at the small building blocks available. What is being sold? What is in the manuals? What are the parts? And then try to put them together in the minimal way that will make the bigger project out of them. And that's really interesting because it's almost like the chips define the computer. The chips define the phone. Now, something like an iPhone was rather special. Look at the greatest products of all time, and very often you'll find they were not developed by a big company. You know, they were developed for one person, even if they came from a big company. They were really developed not to make a big company, but for one person's personal needs that cared so much that they're elegant and they're beautiful and easy to use and friendly, but they also get the job done and aren't confusing. Look at the iPhone. Steve Jobs sitting down and, you know, nitpicking every little detail on it so that he could understand it. It would work in his hands. And he's not doesn't have the time to be a super technical engineer and want this and that and know how to show off 100 features, just wants it understandable. Intuitive is a better word. That's the human world. You got to approach the human world more importantly. But anyway, he built the phone for himself. And now look, turns out there's an awful lot of people that are that way. The masses are very much that way than, you know, the other approaches going for phones and small computers at the time. Look at the Tesla Model S, electric vehicle, electric car. Elon Musk, okay, engineers would look at a project like an electric car and say, what are the pieces we need? What are the components? What do they cost? How can I add it up into a range that cars are sold at? And how can I make it do a useful job for people, like go to work and back? And engineers would not build a large electric car for a decade or more. They built small ones that could go maybe 20 miles to work and back, to school and back, you know, and because the cost of batteries and the weight of the batteries. But Elon Musk had a large family. He had 5 kids. He had to build a big car, a full-size sedan, but he wanted it electric, and he just defined it for his own needs. That car had to be large. Turns out that there was a ton of people in the world just like that wanted the same sort of vehicle, you know, done well, very beautiful and all, very good specs. A lot of people like that in the world. And now we're going to have, you know, eventually that's really the product that'll start, you know, once we have all electric vehicles in the world. But he didn't think, how can I build an electric car? A lot of engineers can do that. He thought, how can I replace my needs in life? My gas car going to an electric car. Gas cars have gas stations. Electric cars have no place really to get electricity for long road trips. And he liked to drive long distances. The first 6 Tesla superchargers, the high-speed chargers that if you drive for 2 hours, you can charge back up in 20 minutes. The first 6 of those were between Southern California, where Elon Musk lives, and Northern California, where the factory was. Such important thinking that really makes the world work came from a person wanting it to work in their own life, but having the right sort of head to do it. My Apple II computer, the product that made Apple, the first 10 years of Apple, all the revenues were from that Apple II computer. I loved video games. The arcade industry was just beginning with Atari, you know, right here in Los Gatos, California. And I sat down and said, wow, wouldn't it be great if these games were color? And I thought up a way to take a hardware game with 1,000 wires and me, an engineer, knowing every signal on every wire and pumping them into a TV to make balls and paddles. I made it software, a number in a computer for $0, not $5,000, will show up as color in every color TV. It's not in any book. It's not even, wasn't even legal by any mathematical methods, but it made the Apple II computer the first time ever that arcade games had color, and the first time ever that arcade games were software. Instead of 1,000 wires with signals, it was just me writing programs to move things. A 9-year-old kid could write a decent game in one day. That was, so these, when you do something for yourself personally, that's where a lot of these greatest products really come from and start with. Mark Zuckerberg and, you know, the Social Network movie, starting out with a personal need right there in the dorm rooms. Look what it turned into. So that helps you assess how much something's worth and it's valuable if it's valuable to you. And if you have a good head, you'll also keep it very beautiful. Business, there are a lot of routes to survival. So you need business thinking. And you need the marketing thinking to know what something's worth, what are the good things to do. Business thinking to say, we keep going. Because if you die, if you're like a company working on a project and you die, or that project within your company dies, well, it is no more. So really, you got to have some people absolutely, you know, making the right decisions in the business world. It's a different world than engineering. Look for your partners, look for contacts, you know, for sales, and partners for sales and that sort of thing. Also, your product, whatever it is, should have some uniqueness, something you can say ours is special for something that the others don't have. That uniqueness really makes, you know, a big deal. And the most important aspect of all, into, you know, turn into one of these big, huge products, successful products, is luck. Is luck. It's so hard to tell what the future really is going to bring. And even if you start going with a good product, somebody else is going to come out and swamp you, you know, cover you up. And it's very unknown when you look far into the future until you're a big company. Once you're a big company, just keeping it going with more big ideas becomes a different, it's not so much you have to hit on an idea nobody else hit on. You don't have to use the same type of brain work anymore.
Thank you. Sure. So you mentioned the social network, which deals with like the implications of like social media on people. What do you think of are some possible implications of using mind control, like we're trying to do to control a robot? What downsides do you see about that?
Well, speaking of social networks and all that, the first thing I think of is, online gaming. Could use your mind to play a game against somebody else using their mind. Now that would be very intriguing. I'm sure it's been done to at least some extent. But one of the things is about using your mind, it tends to always be very slow, the results. Don't think of things in the fast modern world, like as fast as your mind thinks, you can read the data out. I've never seen or heard of it coming about that way. I do like the ideas, you know, where they put sensors on your arms and you can type, and what you type actually types on a virtual keyboard that you can watch on the screen. So there is some positive steps that can kind of come from sensing signals out of the body, but aside from that, yeah, I can't say much.
So I'm a slightly different perspective. I'm a computer science professor here. And I grew up in the 80s coding on an Apple IIe and a Commodore 64. And I always felt like I had, my entire life, I've had a really good sense of what's next and what's coming in technology, personal computers, laptops, mobile devices. And now augmented reality, autonomous driving, robotics are fairly mature. And I feel like it's harder than almost any time in my life to really see what's that big next thing that's coming. I'd be curious what your opinion is on what are some of those next big things that are coming.
Yeah, I'm not sure if people who weren't around then can actually understand it the way those of us who were there. There was a period we went through, a window, maybe of 2 or 3 decades, you know, at least let's say a couple decades, where every week the world was just changed forever, and we saw how important it was, and those days aren't replaceable, exactly as you describe it. We just really don't have that anymore. We have lots of new things coming out and lots of promotions and heavy duty advertising and lots of money to make sure we see all these products, but they aren't just changing the whole world as much as back then. Obviously, with things like Uber, well, look, the world really changed, and a lot of the crowdsourcing that's going on. So those are big changes, but boy, we saw it in our time with products. Actually, hardware products would change, software products would change. Oh my gosh, this small computer now has a database I can really keep and organize my all my address book and everything. Those were just startling. For those of us who lived through it, we think of it, we were very, very lucky to have been alive in that period. I sometimes used to think, oh my gosh, what the kids have at their disposal today. I mean, I wish I was growing up today. And then I always go back and say, no, I'm glad to have lived in the before and the during, considering that we're in the during now. We'll never, we'll obviously never see the end of all this development. You have to figure out, everybody, to one person, what's important in the world is different than to another person. What's important? What are the steps that we're taking that are really good? What am I seeing? So so you can't really pin down like there's one answer for all. But these days, I mean, I look at, okay, I have my computer and I've gone through computer update. I keep up with all the latest, computers and iPhones and stuff. And does my computer life change much since it was 15 years ago? It'd be surprising for you to hear. Not a lot, but obviously you have different ways. You could, one thing is I avoid the social networks. So I'm an old school email. I like to talk about a lot of my aspects in life. I like to go back to old school ways. There are a lot of memories, even when we did things on paper that we don't do on paper now, that are, very good memories from those times that you can't tell the new generation. They only see the status quo. They see how things are now. And that's how it always was developed because it works so well. And the thing is, something that works very well brings improvements to us in technology, always brings some negatives too. Almost always. Generally you get some positive things, but you might have to give up some other good things and just you sort of overlook them. Okay, Facebook lets us all communicate well. And okay, so that makes up for Facebook, tracking us and allowing people to exploit us and that sort of thing, and even influence elections. Oh, well, it's all made up for because we have the good side. Yeah. And sometimes in products, you almost have to say a new advance, a step from an older to a newer. Look at self-driving cars. Are they better? Are they going to be better? Maybe never. Maybe they're never going to have a real self-driving car that looks at the world because no algorithm understands things the way a human mind does. Here's an example. If you show Google 80,000 pictures of dogs, Google can recognize dogs faster than any human. I often use this example. Well, a 1-year-old child, you tell them that's a dog and they know that the dog has limbs and the limbs are kind of hard and they're kind of soft and the limbs are flexible and the dog has eyes and it has a head and it decides where it's going to walk. The child knows what a dog is. And our algorithms don't. We're going so much to this algorithmic world only because it's cost efficient. Costs are really driving everything in life. I hope someday we see a turnaround and people really say, no, I want to respect the users more and let them be able to, if they ever have a problem, reach a human being that can solve their problem. I hope we get there someday. But it's a long shot because, we're just taught, money rules everything. The person who has the most money is the winner.
So Walter's got a hard deadline at 6:20, is that correct? Was you going to finish at 6:20? You have to
Voice
finish
was going in and out.
You have to finish at 6:20, correct?
I didn't understand what you said.
Damn Aussie accent. You have a hard deadline at 6:20, correct?
Oh, 6:20 your time. Yes.
Yes. You have 8 minutes left. So you've got about a question or two left. So make them good ones. You have the same problem I do, but
Okay. So I have a question about how the technology is evolving. Like right now, we are thinking about cybersecurity, data science, because there are hackers everywhere now, and companies need to protect their data. And now, I mean, it's been a month, we heard of Metaverse from Facebook. Like, how do you think about all that, and how can an engineer can adapt to all these changes to think about the future?
Okay. I'm an unusual person in this regard. I was one who never wanted any big money, didn't want to be around it. I have personal values from caring about people to honesty to taking care of those in need. So many personal values that I would never want to be disturbed, and I held out. I knew who I was, and I gave away my big wealth. A lot of people are thinking I just want to go into a big company to get wealthy. I want to go up the org chart to get wealthy. No, know who you are and what you're good at. You know, this is what I've said before, follow your heart. You know, when it came time for me to go to college, that was, a big time because I had somehow taught myself in a day when you couldn't get a single book on how to design computers. I never saw one ever, nothing in schools, nothing in bookstores. And I had taught myself on my own how to design computers, and I could design any computer in the world in about 2 days. If you gave me a good, full description of the architecture of that computer, it'd take me 2 days to figure out what chips would make it. And I was in high school, and I never thought that computer design was even a job in the world. But I had 800s on the math and science SATs, and you said, oh, this guy should apply into MIT. But I flew out of California for my first time ever and went to a place where it snowed that night. And I fell in love with the white snow, and that was the only campus I would even apply to. I followed my heart. Luckily, my parents allowed me to follow my heart. They saw the importance of my happiness, so I made sure that I raised my own kids that way. And you're good at something. I was good all my life in electronics and engineering from 10 years old. Even digital from 10 years old. Great science fair projects and everything. So, I was lucky. I never had to think, what am I going to do in my life? Even out of middle school, I didn't have to think. Out of high school, I never had to go to college to get a job. So I was a very lucky one. But you, inside of you, each one of you, almost everybody has something they love to do. And it doesn't have to be worth money. What I was doing at the time was not worth money. It was not worth a company. It was just because I loved these fun projects that I could show and know I was doing impressive things, but I couldn't ever get any credit for it. I couldn't get, aside from winning science fairs, nothing. So, know what you are inside and be that person and be good at it and go in that direction. Look for jobs. It's also, you say, oh, should I be in a startup that'll make something real big? Well, I developed the Apple computers while I worked for Hewlett Packard. That was not a startup. I had one of the hottest engineering jobs in the world without even an engineering degree, designing the hottest products in the world. And I said, you know what? We're building calculators. Sure, my pastime, my hobby is computer. I love it deep in my heart, designing computers. But I'll work for the man, you know, 9 to 5 job. I'll work for for a real job, like a holding pattern, while on my own time. I didn't waste my life going to parties or anything. I was too much of a geek for that, and too much of a geek to have girlfriends. So I had a lot of time to work on my projects outside of work. But Hewlett Packard. But working for the man is a good holding spot. It keeps you in a position. Your mind is still able to develop. And it's kind of like going to school. You're in high school, you're in the university. It's a nice holding spot to develop your mind because very often, well, drop out of school, go ahead. You'll be working the rest of your life. That's the solution I avoided. So I believe heavily in education. And
Let's see, one more.
ready for more?
Joe, you want your list?
We actually gone through our list.
Gone through your list? All right. No more questions?
I got nothing.
Last chance? Yeah, go on.
No, it's not fresh out.
Fresh out. Okay, well, you've exhausted them.
Thank you.
Thank you so much.
Thank you much.
So thank
Good
you very
talking
much.
to you.
And well, to make sure you get on campus next year.
I have missed that so much, but at least I love reading all the articles about it, largely from Dr. Kubain.
Yep.
Thanks.
Yeah, but we'll to do what we can to get you on campus next year and entertain you properly. Thank you.
I hope these pandemics go away.
Yeah, we're tired of it too.
All right, thank you very much, and we'll see you next time. Okay, thank you guys.
so much.
Thank you.
Thank you.
Thanks for having me.